Good morning, everybody. Thank you for joining the fifth open house discussion on the National Health Stack. So we're going to keep it rolling. We have lots to cover today. The first few slides, as usual, are a quick iSPIRT overview and a health stack overview. All of you by now know iSPIRT is a non-profit tech think tank run by No Greed, No Glory volunteers. Our simple idea is that India's hard problems need a jugalbandi between digital public infrastructure and private innovation. And we hope, many of you are the people who will bring the private innovation to the table to make magic happen as we go forward. Health stack is that public infrastructure, digital public infrastructure that we're talking about. It has three layers. It has the plumbing layer, which is where the focus is right now. It has in the middle an augmentation layer, and on the top, open health services network, OCEAN, we call it. In the way this will emerge is, of course, phase one is plumbing. Phase two is OCEAN. Phase three is going to be the middle layer. Middle layer will come in a little later than the other two layers that we have. And, very often when you want something to happen, you will end up using some elements of all the three layers. And this is a scenario that I've covered in previous open houses, so I'm not going to cover it in detail. If you want to hear about it, you can go to one of the older ones. But essentially, if you want a golden scenario of teleconsultation to emerge, then for standard of care to improve, you need 1, 2, and 3 to happen. And for a kind of an open, transparent, trustable handoffs to exist, then you need 4 and 5 to happen. So this is really a background. We've been talking about this roadmap from the beginning. The difference is that doctor registry, because of the connectivity that we need on the back end with the people who issue the degrees, is running late. We now hope to have that up and ready by 30th of July instead of 30th of June. So this is the backstory. Today, a lot of discussion is actually going to be about personal health records. I want to say a few words before I hand it over to Sid. Many of you, saw the APIs and the sample code on 23rd May, which is exactly 6 weeks ago. And I'm so happy to say that today you'll hear 6 players talk about using this and bringing this to life, and they'll share with you what is happening. And this kind of a mindset is very, very important, because what we want people to do is that as public infrastructure becomes available, people should jump in, dirty their hands, try it out, give feedback. And once they have fully understood what this is about, then go back into their business mode and assess for themselves whether this is going to be important for them, for their company in the future. And if they feel that this is important for them in the future, then they double down on it. And if they feel this is not going to be important in the future, then this was an experiment that they did, and they took a more informed decision than would have been the case had they not done all this dirtying of their hands. So this is the modality that we are trying to promote very aggressively. And so therefore, the 6 players that you will hear about today, to my mind, they are the hero players in the industry, because they're following this approach, right? And this is not conventional. We tend to wait for things to settle down, everything to become clear, and then kind of jump in. And in fast moving technologies, that makes things, it is generally too late to do that. So the 6 players that you hear from today, they are the emerging kind of example setters in our ecosystem. And I have to say this, and I'm sure Sid will amplify this. The best example of that is Dr. Pramesh from National Cancer Grid. And without his early embrace of this, this won't have made the progress that it has. So with that, let me hand it over to Sid. Sid, over to you.
Thank you so much, Sharad. Absolutely. I mean, yeah. As Sharad outlined, I think the 6 folks would be, and they represent diverse range of companies building in this ecosystem today. So we've got folks building out API bridges. We've got HIPs and HIUs themselves. We've got folks building out consent managers and health lockers for the consumer. So essentially a diverse range of folks that each one of whom are playing an extremely key role in bringing the PHR experience for the consumer across this entire ecosystem. The way we'll structure today's session is we'll have a quick 3 to 5 minute overview by each of them into what they've built and how they see that particular part of the ecosystem, be it the bridge or the health lock or the consent manager and so on, shape up. And we will then open it up for Q&A in the second half. So to kick it off, I'd like to invite Dr. Pramesh, who heads the National Cancer Grid. As Sharad outlined, the National Cancer Grid was one of the early adopters of this entire framework and believed in the power of empowering every individual with control over their health data. Not only that, along with the ThoughtWorks team, they went on to even implement the first version of it that's out there in the open source. And so, yeah, it's been absolutely amazing. So with that, Dr. Pramesh, would you like to take over?
Yes, thank you, Sid and Sharad, for the opportunity. I'm very aware of the fact that I'm trying to talk tech to a bunch of tech folks, and I'm probably the least qualified here to speak about this. But nevertheless, the fact that we used some of these much before COVID came in, which has kind of precipitated the need for solutions like this, is where I'll take off from. So I'm aware that most of you are not from the healthcare space, so I'll give you a minute to understand what the National Cancer Grid is about. So this is a study that we did along with one of our collaborators, Swasth India. Ankur is someone you might know, where we geotagged 75,000 patients who visited the Tata Memorial Hospital over a 6-month period. And for those of you who know where we are located, which is Mumbai, this density of patients that you see coming from the state of Maharashtra is no surprise. But what you see here coming in from the vast majority of the north, the northeast, and eastern India is certainly a cause for concern. And from our own data, we understand that 60% of our patients come from outside the state of Maharashtra. So we realized that we needed to fix this solution pretty quickly, which is the reason we created this vast network of cancer centers, which is about 8 years old, funded by the Government of India through the Department of Atomic Energy. And currently, what started off as a very small enterprise with just 14 centers is now at 220 member institutions which are part of it. And these are predominantly cancer centers, both from the private sector as well as the public sector, and a handful of research institutes, patient groups, and professional societies. So as you can see, the length and breadth of India is covered. And between these 220 centers, we treat 700,000 new patients with cancer annually, which is approximately 60% of all of India's cancer burden. So the impact for something that's implemented within the National Cancer Grid is pretty huge. So about a year and a half back, we threw out what we thought was a grand challenge in health data. And we've been discussing this in 2 previous National Cancer Grid annual meetings, where we felt that the need to aggregate patient data, and I'll come to the wish list in a minute, was something that we've not done very well. And if you ask anybody who uses any form of electronic medical records, however sophisticated it might be, you'll find more pain points than pleasure points in them. So the wish list that we had from patients and doctors were the following. And this is the challenge that we threw in the workshop that we did at Bangalore a year and a half back. What patients require is ready access to digital health records from all sources. So from our own experience at the Tata Memorial, when we had physical files, and we stopped having physical files about 8 years back, 30% of physical files used to get lost. Either they get caught in a fire, lost in floods, stolen from a train, whatever. And we realized that having ready access to health records was important, and ready access to digital health records has benefits which I don't think I need to explain to any of you. The other requirement from patients is the ability to securely share health records with healthcare professionals remotely. I use the word securely and remotely, not frivolously here, because security of patient health records is something that's extremely important, both for us as healthcare providers, as well as to patients as the consumers. and the ability to provide, be able to do this remotely, as you saw from the graph that I showed as the patients who land up at Tata Hospital. This is something that's common to both patients and doctors. The need for electronic records should not take away precious time from the patient-doctor consultation. It is estimated that in the US, 80% of an average interaction between a patient and a doctor is spent in inputting the patient records into a digital format. This is in the US, where an average consultation time is approximately 30 to 40 minutes. Come to India, where the average consultation in a public hospital is anywhere from 3 to 7 minutes, and you realize the magnitude of the problem, wherein the very precious patient-doctor relationship is compromised because of the need for inputting data into electronic records. And finally, from a doctor's perspective, it needed to be something that was least disruptive of the current method of functioning. The wish list from the researchers and policymakers were different. The predominant requirement being that we needed to be aggregate data across electronic health record systems. One of the biggest pain points that we have now is the inability to do so, even between centers which have similar electronic health records. Forget about having different types of health records. I have posed this challenge to at least 6 or 7 startups. I'm met with this very standard response that this is child's play. You can easily aggregate the data. What we need is a bunch of APIs, and we'll all get it together into a single database, which you can analyze. And 6 months later, most of them come back and say, it's a much bigger problem than we initially thought it was. So I'll illustrate this with an example. The current Indian Council of Medical Research has registries which currently cover about 10% of India's population. Just imagine an ecosystem where every single National Cancer Grid Center had electronic records which could then get aggregated. You would be able to multiply this 6-fold without practically any additional expense. So this is the kind of exponential increase that we are looking at, and what we should not settle for anything lesser. Finally, for researchers, data analytics, the way you would do for a Google search or a PubMed search, for those of you who are interested in searching for medical literature. For example, from my database of 3,000 patients with breast cancer, I want to know what's the 5-year survival of patients with X type of breast cancer treated with a shorter regime of treatment compared to the longer regime. I should be able to use a few search terms, filter them out, and get these answers at the click of a button, which is the kind of challenges we put. And I'm sure that most of you would understand and accept that these are vast challenges which still would be pretty ambitious to embark on a war footing. So which is why we broke this down into simple problems. And the first problem that we took on was, how can we enable sharing of data between healthcare providers and for patients to be able to enable that. So what we created was a simple system where the health information providers are listed here on either side. You have a registry, which is a national registry of doctors as well as healthcare facilities. And this could involve blood banks, labs, imaging centers, and so on. And you have patients here enabled with just a phone that gives them access to all of these. You have a consent manager, which is extremely robust, and I'll come to that in a minute. You have the gateway, which actually enables this exchange of information across the healthcare providers, again, with the consent of the patients. And this is work we did with a lot of inputs and advisory role from iSPIRT, but a lot of the implementation actually came through with ThoughtWorks and their group based out of Bangalore. And this is the kind of data transfer that we wanted. A secure and safe data transfer with linkage to patient records only with patient's approval and authentication, which currently we use as the mobile number, but which could practically be anything else, just like you would get a bank transfer being done with multiple forms of authentication, either an email ID or any form of OTP-based system. And the exchange of data could only be possible with the explicit consent from patients. The health information user is the only person who can access the data. Even the consent manager does not have the ability to access the data. And these would obviously meet with industry standards as far as security, encryption, and the transfer are concerned. At any given point of time, we wanted the patient to be able to revoke consent, in which case the data is automatically purged from the HIU, from the doctor's interface. It also gets automatically purged whenever the consent expires. And this consent comes with an expiry period, which we wanted to build into the system. And all data that is received at the HIU is encrypted and secured, and only the requesting doctor has access to the feature. So this is the way we broke it up. So we initially thought we would have an initial proof of concept, which I'm happy to say is completed and ready to roll. And we initially had thought that we would make it in two additional phases. The second would be to make it feature ready and scalable. And the third, which we to make the scaling pretty elastic and a large part of the monitoring and the management automatic. So what we've done so far is to establish a shared understanding of the problem. We've done a smaller pilot involving a few of our partner centers within the National Cancer Grid. We've had working prototypes, which we've demonstrated, and several interactions. And we've looked at several types of data, including imaging data, the regular text form of data, and to identify the challenges and issues that are involved in this. In the second and third phase, which was supposed to be phase 2 followed by phase 3, thanks to COVID and the urgency of the situation, we've kind of combined it into a single phase. And much of the comprehensive features that we wanted to get into the second and the third phase are already done. The user experience and the feedback from the users have already been incorporated. All of this happens in real time. And we use state-of-the-art engineering to do this. Scaling up is automatic, updates are automatic. The management and the maintenance, especially which with an enterprise like this with 220 odd centers needed to be monitored, also needs to be automatic. And the scalability again needs to be elastic and extensible as we go. So I think I'll stop with that, and happy to take any questions at the end of all the presentations.
Thank you so much, Dr. Pramesh. And building on what you've just shown us, where through your member institutions, you're making their health data electronically accessible, that now brings to life the possibility of remote care. And so I'd now like to hand it over to Dhruv and team at iClinic. iClinic is a teleconsultation platform, and essentially it's a vehicle for the delivery of remote care, and for them, access to health data and patients' health data becomes critical, so that the doctors on that platform are able to consult and provide the right diagnosis and care treatment protocol. So over to you, Dhruv.
Hi, Sid. Thank you for getting us on today, and thank you for the participants here. So the workflow which we thought we should show here is that how it works for a teleconsultation platform like ours. So a little about iClinic. So we are actually a global medical second opinion platform, and we started focusing on the Indian markets in the last 3 years actually. And one of the key things in India is that the records are in silos. And most of patients are in the US, so we are used to working in the US format of things. Thankfully, now we have the national health stack coming up. I think which is going to literally change the whole landscape. So now with this whole flow, what we think is that the lab investigations or medical history or prescriptions and consultation summary, and even a medical second report can be moved between doctors and different HIUs in a very seamless manner. And of course, it has to happen in a secure environment, and being HIPAA compliant platform, we already adhere to it. And I think it's also very important that other players who want to latch on the system also follow it in a similar kind of system. And of course, we also generate lot of data. For instance, right, our consultations results in a consultation summary and your prescriptions coming out of it. And we also have various insurance players generating medical MERs from iClinic, because they use this to evaluate their patients and get those things on board. And we also have various tools here. For instance, we have a BMI tool. We are also working with a player from Israel, where by just looking at the phone screen, you would be able to collect your pulse and SpO2 and all those things. So we are working on it right now. So that's going to probably help during times of adversity like what we have now. You need not go buy a pulse oximeter. You could get the report there, and this can be shared seamlessly as well. So yeah, I think this is what is more interesting, right? In a country like India, the patient-doctor ratio is really not up to the standards which the WHO wants. It's 1:, it's not 1:1,000 which the WHO wants. It's like actually 1:1,445. And there is severe shortage of specialists. I think doctor here would agree. We have less than 30,000 gynecologists, and oncologists are like really low. Again, we have less than 2,000 in fact, and dermatologists also are really less. It may seem to us that a lot of doctors are on, but again, in reality, the specialists are too less. And all we have to do is that we have to make sure we optimize their time very well. And most of the time, when you have records flowing in silos, and you waste the doctor's time here. I think even if the patients upload their reports by themselves, they do not add the photo in order, or they do not add the reports in the right heading. These are all the issues which we have always encountered with patients here in India. And one more thing is, right, when doctors ask a question, they again do repeat repeat lab investigation, because they lose the previous record. Medical records are not well respected in India. I think one has to look at it as much as how they have a financial bank balance. Right? And of course, the last point in the slide is just want to put as a small fact, right? It's a treasure. Medical records are really a treasure. So because again, most of them, when you go to doctor would write, would note down a particular allergy and write down a sulfur allergy, right? And what happens is, when you go for, when a patient is suddenly operated and he goes for an emergency, seldom the allergies are known to the person there. So this is the workflow here, and I think this is better shown by my CTO here, Marshall here is here. So probably you can talk about the workflow.
Yeah, hi, Marshall here. So this is the health information user teleconsult workflow. So here the user will first initiate a share index from a HIV app like iClinic or any other HIV apps as well. So these consult requests will be then sent to the bridge gateway and for validation and verification. So once the verification goes with the user, and the request will be go to the corresponding HIP for the data request or the data payload, whatever it is. And the data and the HIP will then forward the payload to the bridge, and then the bridge will be, send the data back to the HIV and it will be shown to the doctor with all the schema like expiry and all the things will be covered.
So we thought we can show a light demo here, so it'll be easily understood for all of us. So this is a typical this is a test environment actually. So we thought we'll show it here. I'm just posting a question here on the platform. Say hi. Let's go to the next step. These are standard steps on the platform. And it's always mandatory on a platform to choose the patient's profile here, and it's already loaded. And here comes the area where the NHS parameter comes into focus. Right? I click on this, and there's a consent manager coming here. I can probably say, what say something like M5. On it. And I get an OTP. I mean, the OTP could either come there, or we just put it here in case you're able to build it here. It's good, so we just put it here. And then you have the reports, which is already in the consent management. Various you have reports from Thyrocare or Apollo or iClinic or Columbia. I can just attach cited fields. Sorry. Yeah. I can also browse and see the cited files. The notes are here, and it keeps going. And I just click on submit. Once I click on submit, the report comes here, and then it's it. That's it. It's as simple as this. I type the other complaints. I just click on proceed to pay, and it's here, and it's all done. The records just reach the doctor. As simple as that. That's all. That's what I want to show here on the patient side. On the doctor's end, it's just the same records will be shown to the doctor. I think when we were running through this with our moderation panel of doctors, we figured out that the time saved for any consultation in records is going to be at least 50% of a doctor's consultation time. So, which means that we'll be able to do wonders with this. So yeah.
Awesome. Thanks a lot, Dhruv. And to enable HIPs and HIUs like Dhruv and the folks part of Dr. Pramesh's team, you essentially need a very strong ecosystem of technology partners, what are more commonly known as API bridges. And so I'd like to request Abhimanyu, the founder of Live Health, to now come up. Live Health runs the lab information management system for majority of the labs in the organized sector today. And they are one of the early implementations of the API bridge that allow for labs, large and small, to actually plug into this framework and enable sharing of the patient's health information.
Thanks, Sid. So I'll just quickly start with the presentation. So when we first started off building a technology solution for lab automation, we figured that eventually many will want to get lab data and actually transact with it, and they would like to build on that for building an ultimate system of engagement with healthcare providers, like what Dhruv talked about. And one of the key cornerstones for this is actually organizing the medical record at the source and getting it to the health, like getting it to the final user. And we figured that we started an effort to organize all the network of labs that we had under one single API to transact. And one of the key challenges that we started facing soon was how do you make this adopt across multiple providers. So I think what NHS does is allows you to like really standardize those protocols. So like essentially to begin with, so we have one single API to transact with all healthcare providers with the help of a bridge. And more importantly, a raw parameter data is available for HIUs actually that can finally use them for patient engagement and driving more personalized records. And it's standardized. It's actually available for everyone in the same format. The protocols are the same, which makes it which actually makes everyone talk the same language. So we implemented this in phases. So the first phase was actually implementing a bridge, and one of the key things that the bridge offers is it allows the entire network of 1,500 labs to be accessible via one single bridge that can then be accessed by any HIU or in fact any other HIP as well. So we did a so our implementation was actually not something that was built with the Live Health app, but which was built outside, so that we can actually use this for a long-term vision where we can start using the bridge for third-party HIPs as well, who are not Live Health customers. But the bridge is actually an independent entity residing in the network, and essentially it's a system of its own which can transact with multiple healthcare providers. Our implementation roadmap isn't looked like getting the bridge, the doctor and provider registry implemented and up and running by September 20th. By the end of this quarter, large part of these implementations would be done in the next month. Major rollouts would start next month onwards. All 1,500 laboratories would be registered and ready for use at the time of rollout. So all Live Health customers would immediately get the benefit, and then start rolling this benefit out to third parties who don't have immediate API bridges to work with. So we essentially use our experience and knowledge for managing diagnostic records with laboratories to apply that for larger laboratories which are probably not using our services but still able to transact with each other. And finally, we are actually excited also about getting more insights out of the report. So not just delivering the simple medical record to the endpoint, but also looking at how do you drive insights out of that data for criticality and abnormality. So yeah, all in all, this is currently where we stand. And yeah, it's been like, I think the overall overall health stack has been a lot of benefit to fast track this process and get this out and running to everyone. So yeah, thanks for the team as well, the iSPIRT team. Yeah.
Thanks a lot, Abhimanyu. In fact, when you look at the problem of health data from a systems view, you often, and from essentially an individual wanting access to their health records right from birth till before they die, right? Because that's where records like vaccination and so on become important. A lot of times these providers will partner with API bridges, but what may happen is some of these providers may shut down over a 70 to 80 year time span. In fact, they will. And what happens to accessibility of patients' records then? That's where the notion of a health locker, a personal health locker, comes in. And so I'd like to call in Sohit, who is the founder of Briefcase, to talk about their attempt in building out a personal health locker, whose sole goal is to create for the patient, with their consent, that birth to death record, longitudinal record. So over to you guys.
Thanks a lot, Sid. I hope you guys can see my screen.
Yes.
Yeah, so Briefcase was started in 2016 with precisely this objective of building a personal health locker for consumers or users in India. And over the last 4 years journey, what we realized is that it is an important part for the users. However, given that the user records are so fragmented, lying at different places, there are times when users don't have access to all the records. They may have lost them, or probably the most important reason is the user inertia. The user just does not want to take the time or the effort to load the records on their own. So we have over the last few years taken steps to make it easier and easier for the users to kind of get all their records at one place. Some of those steps have shown good results, and from our perspective, national health stack kind of brings that to another level completely. It takes away the F and at the same time kind of gives the user complete control. So this is where we see the national health stack kind of playing out, and how the health locker provides the advantage to a user. It is so, as national health stack talks about a complete control to the user with respect to sharing of records, the health locker adds a layer where it's not only control on sharing but control on the records. So the records are with you. And as Sid mentioned, it's not that the records are you for a particular point of time, or you're relying on a particular healthcare service provider. They are with you for lifetime, or as long as you want them to be there. Also, it gives you a real-time access. So, the records are in your secured storage, which can be accessed on a real-time basis and does not need to go through the whole consent mechanism every time. So that kind of saves it time. In times of emergency, you can just pull out the records very, very quickly. The health record also helps you bring your past records in the PHR system. And those past records may be in physical form today. So the health locker can help you kind of bring all those records onto the platform, and hence then become shareable to the wider ecosystem. And lastly, it provides an aggregated view to the user. As we know, till now, the only aggregator of medical records in India was the patient herself. With the health stack coming in, some part of that gets taken care of, and this can build a layer on that. Talking about the implementation of the health locker, it's essentially a simple HIU HIP combination of implementation. So taking an example here, so your user can kind of register with a health locker and upload her medical records, her physical records, and all at the same time through the consent manager can discover all the health records that are out there in the system. So whether it's labs, hospitals, clinics, any HIP which has her records can be discovered and linked through the consent manager, and the records can be pulled out. Just a couple of nuances here. it's not just the linking of records that happens. You actually get a duplicate copy of the records and store them in the health locker. So going forward, you don't have to just kind of rely on the HIPs, but you can just pull out the records from your locker as well. The other nuance here is, of course, an ongoing or a standing consent that the health locker has, which is, of course, revocable by the user at any point of time. But what it does is it allows the locker to be regularly updated. So you could have some kind of a mechanism where records keep getting pulled, and we are working through the steps to see if the HIPs can push these records directly on creation. If not that, then the health locker can regularly ping the HIP on the basis of that consent and pull out the records. So that takes care of the loading of the health locker and which is the HIP kind of, sorry, the HIU kind of implementation. Now moving to how do you share records from the health locker. So a case where the health locker acts like an HIP. It works fairly in a standard manner, again, like any other HIP or an API bridge, as Abhimanyu was talking about. So, the HIU requests for the documents, and amongst all the options that you see as an HIP, you'll see the health locker. And again, we can work through the modalities of whether health locker takes precedence over other HIPs or vice versa. And the records are then shared with the HIU. Something we are also looking at trying to figure out a bit more is, can the user also proactively share records with the connected HIU? So again, it's not only driven on a request from the HIP, from the HIU, sorry, but it's also if the user has gone for a consultation and believes there are certain more records that can be shared, whether she can do it. So that's the implementation of the health locker. Happy to take any more questions on this at the end of the session.
Awesome. Thanks a lot, Sohit, for your presentation. We've so far seen essentially clinical use cases of health data, but another important use case is, could a individual use this to fast track the processing of their claims, and as a result obtain various new types of insurance products, either wellness-driven health checkups and so on. And for that to happen, a key part of claims processing becomes auto adjudication, which means those systems require access to machine readable and digitally signed data. So I'd like to call on Anurag. Anurag is the CTO at Bajaj Finserv Health to talk about how they're looking at it from a claims point of view and the overall ecosystem. So over to you, Anurag.
Yeah. Thank you, Sid. Let me just share my screen. Hope you all can see my screen. What I want
No, we're not able to see it, Anurag. No.
Oh, okay. Oh.
Yes, we can see it now.
Okay. Yeah. So essentially, I want to just cover what Bajaj Finserv Health is about. So our business vision is very simple. We just want to become the biggest payer for healthcare in India. And we are essentially a tech entity, and we are giving a single face of Bajaj Group to both providers as well as consumers. By being a single face, so when we say Bajaj Group, so we are into both EMI financing for your IP treatments in hospitals, plus we give insurance. And what we are trying to do in insurance is, standard insurance typically covers only IPD. And what we are offering and bringing with the new thing idea is guiding is to also offer OPD and lab coverage as part of the insurance offering. And we are calling that as a full-fledged managed care product. So where we will manage end consumer's health end to end and help him keep his health better. And one of the key innovations that we need to do here is today a claim gets processed. Just the whole cost to process a claim is close to 500 rupees. And if I have to cover OPD and lab coverage, those costs will not work for us. So we have to bring this cost to rupees 5 or lower on the claims that we want to process around OPD and lab coverage. So that's our intent for which we are building all the tech stack. So this is again very simplistic view of what is an EMR, what is a PHR. In our view, EMR is something that is supplied by the provider, and labs. PHR is something that gets shared with the patient or they can upload on their own. And this combination is EHR. So I just want to quickly cover our tech stack here. In very simple terms, it's a microservices and based and fully scalable on cloud. And we have two major components in it. The first major component is basically the whole ID and access management, because we will get data from multiple labs, and customers can also upload data, and hospitals will also share data. Now, why will that data come to us? Why will consumer upload here, or why will labs share data with us? Is because we are the payer here. And when we are paying, when we are covering, then for all the claims, the data will come to us, and so we become automatic keeper for that also. So that will become one of the major incentive for the data for people to keep it in one place. And we are building this system in a way that data can come from multiple providers, multiple ways, while it become normalized when it is coming at our end. So, and also we do ID and access management. So when I say ID and access management, so we also look at how can we match user coming from one lab versus when he visits some other lab, and the data flows from two different labs while it links to the same patient in our backend. So we use a very simplistic view of that a person's phone number, first name and last name will be the unique identity at our end, which we are going to use for identifying a patient. And the patient can always claim his records with basis of using our app and doing OTP based validation. And he can also use the app to maintain all health records for his complete family. And we also maintain mapping that once a provider they can give their own unique identifiers also while working with us. And later on, they can keep querying using their unique identity with us. So that will also ensure if someone is changing the number later on, but the unique ID will carry on, so the record will continue with those IDs with them. So that is how we have built whole the ID and access management piece. The second piece that we have is the health ward, where we are keeping the lab data and person's profile, disease history, his vitals, especially his trends around vitals from wherever he is uploading can be looked at. Prescription can come both from, say, e-consultation platform, a digital, and it can be stored in a structured format, or it can come as just a photo, and we do OCR and make it again searchable and structured as much as it is feasible. Again, we have immunization record into it and discharge summary documents, which are again in a searchable format. So right now we don't have a structured discharge summary, but anything which is in there is fully searchable, and all those are powered with a combination of a NoSQL DB and Elasticsearch and Redis and Azure Blob combination. And this is how we are currently building up our consent framework fully on the lines of the way NHS is building. But the way we are also looking at what is the green part is already built is where the partners is pushing data into our PHR, and they use their UHID. We internally maintain a PHR ID for that one. Secondly, patients can, or they're also pushing data into our PHR through our mobile app, which is available on App Store and Play Store. So even when a patient uploads a lab report or a provider uploads a lab report, the photo also gets OCR'd. It gets basically normalized because lab information can come in different formats. We convert that with an algorithm we have developed into LOINC, and then store in that LOINC structure at the back end. Because typically a doctor and the users look for trend for values. And those trends can be drawn only when we convert those to LOINC codes. So those are the normalization we are doing upfront while storing this data. And what we have also have is a doctor side app that we have also giving to doctors to use as a, if they want to consume information. So we have that built where a doctor can get access to the patient's health vault if the patient has given him consent. So today we have built it using an OTP based sharing. Tomorrow with NHS we can look at more API based access as well. And we have also made it more API bridge driven, so that if some other EMRs or say teleconsultation or other software, they want to access data from our health vault, we will also have open APIs to work with them, so that the patient who is going to those hospitals or using those softwares, the doctors there can also get access to the health data stored at our place. And this is the part I think we will want to work most with other providers, so that we can do those interworking with the framework that is being built here with iSPIRT. Thank you. I think we can take more questions towards the end.
Cool. Thanks. Thank you so much, Anurag. And we almost near the end. We now have, much like the NCG group, which is a network of cancer hospitals, there is the Swasth Alliance, which is a network of telehealth platforms and beyond. And so I'd like to invite Ajit, who's also the CTO at mFine and anchoring the implementation of PHR within the Swasth Alliance, to share how they've been thinking about it and the stuff they've built so far.
Thanks, Ed. Just sharing my desktop. Okay, so my name is Ajit. Like Sid mentioned, I'm the CTO at mFine, but today I don't represent mFine. I'm here to represent Swasth. Just as a quick background, this is an alliance that we set up between many health tech companies and health companies, hospitals, and so on. It's a consortium that we set up just 3 months back. So we are just 3 months old. And our basic goal is listed, as you can see here, is to actually provide access to doctors and create that public good in the crisis, in the COVID crisis that we are seeing, right? So we came together at that precise time when we went into lockdown. And in the 3 months, we've tried to sort of bring together various pieces, provide the user experience, bring the doctors, give the access to a lot of patients who are looking for that access today. And in the process, also do enough to build sort of publicly available infrastructure, which can then be used and extended for making India truly a digital health country, right? So that's the goal. So what do we offer? At Swasth, we basically provide basic teleconsultation, but also try and tie in with other services like medicines, diagnostic tests, at-home care, and also visibility of hospitals and beds across the country, both private and government. This is what we do today. So a basic flow, somebody could just go to swasth.app, that's the site, and you could start a basic consultation with either in English or Hindi, and it takes you through a very simple a basic intelligence system which lets you talk through your basic problems. At the end of the automated flow, you are connected to a doctor, and the doctor is looking at your condition either through an audio or a video call, and in the end, passing on a prescription to you. Right. So that's the flow. And at the end of that prescription, the user is then able to place an order for medicines, either to be picked up or to be delivered through one of our medicine delivery partners, or could also get into a diagnostic flow where he gets the test done and so on. Right. So that's the sort of use case that we are trying to solve. And just want to take a few minutes to explain what are the pieces that we built in the process. So we go in two modes. One is the user application, as I just showed. That is track one that we are building. But on the track two, we are also building towards the national health stack, trying to build in line with what Sharad and Sid were mentioning, and also what you have seen through in all of the earlier webinars. So let me just quickly take through the track two, which is important here. This is precisely what it looks like today. So if you look at Swasth app today, it is one of the telemedicine app and connecting to a multitude of providers on the right hand side, right, which are either aggregators like an M-Fine or a Practo, or they're hospitals like Apollo or Apollo 24/7. Any of these players could be on the right hand side, and the goal is to actually allow the consults to happen from Swasth to any of these players. So if you remember Sharad's first slide, he talked about three layers. Actually, he talked about the core layer, which is the focus of the discussion today, which comes in forms of the registries, the consent manager, the PHR, the e-voucher, and so on. But he also talked about the ocean layer, and our goal was, together working with iSPIRT, to actually seed this layer as well. So in some sense, you can say we are sort of co-creating this with iSPIRT in the lines of UPI and the general guidelines that has been laid out. That we start from here, we provide the basic end-to-end service layer for teleconsultations at this point, and then meet in the middle when we have the pieces that we can consume from the national health stack, and which we are in the process of doing. So as we stand today, we have basic teleconsult gateway at the ocean layer. You can call it a version 0.5 or even lesser, but it's a start nevertheless, which connects the Swasth app to any participating providers. And there is a set of documentation and APIs, etc., that is available for people to plug into it. And as a step two, what we are doing is we are starting to use the consent flows. Why? Because once a patient has done one of the consultations with one of the providers, and if he comes back for a follow-up, and he comes back at a later point in time for a new consultation, then the data needs to flow between these two providers. And that's where we start to build the flows of the consent. And that looks somewhat like this, right? Today, Swasth app is in the gray. We have a telehealth gateway as part of the ocean layer, and we have a couple of players already implementing that stack. What we are introducing is the consent manager on Swasth, the Swasth consent gateway as part of the Swasth network, and of course the HIP, HIU bridges that each of these players have to implement. So what is important to note here is also that we get two advantages here. So one, while we grow on the ocean layer to get more providers to adhere to a service specification, but in doing so, because we build the consent flows as well, we are getting some of these players also implement the consent interfaces as well. So actually, I see this as one implementation, but actually you get two benefits, both that we progress on the ocean layer and the core consent PHR flows in one shot, right? So we are in the process of doing that. There is a basic workflow and everything else that we have created. We have already had a couple of discussions with the iSPIRT team as well to sort of nail that down. In the next 3 to 4 weeks, we will have this flow of patient-consented flows and data flowing between the multiple providers who are attached to this Swasth network for teleconsultation. And in a further extension to this, we will also be working together with the iSPIRT team to sort of build the inter-gateway peering protocol, which will also be necessary. For instance, like we have a similar consent manager and gateway at the NCG, as Doctor was mentioning at the beginning of the presentation. What if you have data that is spread across multiple consent managers? Then you need some sort of a peering protocol between the gateways to actually have seamless flow of data between any provider and any user. So that's the next step for us. But largely, this is what we are doing as part of the Alliance. And just to remind you that Alliance is, I think many of you here are probably part of it as well, close to 50 or 60 odd companies that are together driving this and creating something for a public use. I think this is phenomenal as well. That's it, Sid, from my end.
Thank you so much, Ajit. And I'd like to thank again all the other panelists, Abhimanyu, Anurag, Dhruv, Dr. Pramesh, Sohit, for actually sharing the work that's happened over the past few weeks on the back of PHR. In being mindful of time, we would not be able to take up any Q&As today. And so that we will roll over into the next session that will be on the 25th of July. What I would like to talk about on the PHR side is there will be a new version of the standard based on the various feedback that's been received and the implementations that have happened. There'll be a new iteration of the standard being published this weekend. And as we mentioned in the roadmap, certification against these APIs will go live 27th of July onwards. So if anyone has implemented it either as an API bridge or a HIP, HIU, or a consent manager, or you build your own gateway, you will need to get certified, and that goes live 27 July onwards. I'll now hand it over to Sharad.
Yeah, so in addition, we'll also cover the business model of PHR in that next open house discussion. The point I wanted to end on was to implore you, look, this has been 6 weeks and you've seen this progress, and things are going to move pretty quick from here. And it requires a kind of a new type of mindset. We call it dual immersion. And dual immersion is part of this notion that in these kind of playgrounds that we are talking about, you need a new player. We call it sometimes, to bring home this idea that you need a new player, we call it the athletic Gavaskar instead of a Gavaskar that you need. So what's the difference? The athletic Gavaskar, of course, is athletic. And Gavaskar, he was so successful as he was, there wasn't, he didn't need to become athletic. But cricket changed. It was now a 20-over game, and you couldn't thrive in that game until you had athletic Gavaskars driving it. And that was an effort that resulted in a new under-19 team being created, Virat Kohli going on to become the captain of the team, and now most of our cricketers are very athletic. Now, this happens not just in sports, it also happens in the area of entrepreneurship. And one of those things that you need is what we call as dual immersion. What is dual immersion? Dual immersion is that you are immersed in the problem that you're trying to solve, which requires domain knowledge, knowing the health system inside out, but it also requires you to understand the messiness of the new infrastructure that is coming in. And both of these things are messy. Problems by definition are messy. New infrastructure by definition is messy. And unless you code yourself a little bit to say, I am going to organize myself, my company, my team to live in the midst of both of these messinesses, you will not get the results that you seek. So if you shirk the messiness of the problem, we know you won't succeed. If you shirk the messiness of new infrastructure, then also you won't succeed. So we want to end on this note, imploring you to embrace dual immersion and move quickly, move fast. These are good times to build on this new infrastructure that is coming and bring this to reality there are lots and lots of things in the pipeline. So keep a watchful eye on what is happening in the coming weeks. Thank you so much.
Thanks a lot. Thank you. Take care.